Hi, in this video I'm going to be looking at switching power supply modules. These are modules that you can commonly buy on eBay or Amazon or AliExpress, and you can use them to build your own laboratory type power supply. You can get a lot of functionality in a very small module, and usually they have a pretty decent user interface. The first one I'm going to look at is this DPX5005. I think this is probably the most popular one that you can buy online. It's a nice small module. Then I'm going to look at the RD6006, a lot bigger, but with some additional features. I think both of these are made by Rudin or Rudy Yang. I think I got them both from the same place. And then I'm going to look at this other one here. This is a DPX6005. I don't know who makes this one. I tried to get also a DPX3003, but apparently those are no longer made. They only sell these 6005s. So those are the three modules I'm going to try out. So in order to power these, you need to use an AC to DC converter. Now for some people that might sound a little bit odd. You're using a power supply to power a power supply, but these things are strictly DC to DC modules. You'll need some kind of a power brick or another power supply, something that will output voltage go into the input side of this. So like this here, this is a Cisco 10-port gigabit PoE switch power supply. I think it's 48 volts at 2.5 amps. This is the kind of thing you might want to use. I'm not actually going to use this because it has this wonky DIN plug on the end that goes with one of my Cisco PoE switches. Instead, what I'm going to use to power the modules themselves, I have got out my ginormous Mastech DC power supply, because I think what I want to do is I want to power these modules with 48 volts at a couple, 3, maybe 5 amps. So give plenty of input power budget in that. That's over 200 watts of power going in. To test these power supplies, I decided to make myself yet another DC load, resistive one. You may remember I made a resistive load in one of my previous videos. This here was a 1, 2, 5, and 10 ohm resistor. I believe they were each 50 watt, and you could turn them on and off individually and get yourself a wide range of resistance values. So I have made myself another one because I wanted higher wattage. I wanted to be able to put a bunch of equal resistors in parallel, have them each share the wattage, and be able to test one of these power supplies up to 100 or 200 watts. So I made this one. In this one, I went with 4 100 watt 30 ohm resistors. So if you put 3 of those in parallel, the parallel resistance formula will tell you that you will get 10 ohms out of 3 30 ohm resistors. All 4 of them will give you 7.5 ohms. So that gives us 10 ohms at 300 watts or 7.5 ohms at 400 watts. That should be enough to test any conceivable power supply project. Or so I thought. It turns out these things do still get really, really, really hot. Even though these are 100 watt resistors, I think the standard rule of thumb is you have to derate them by about 50% unless you have a humongous heatsink. And I really don't have much of a heatsink, I just have this case. So maybe this is good to 200 watts, but even at 75 watts it still gets really, really, really hot. So I added this Noctua fan. It's just wired to a plug on the back, and I will let that run to do some cooling. So what I really want to do is get myself a nice beefy active load, like a 400 watt active load. I've actually ordered myself an active DC load from China. Ought to be here in about a week. Maybe I'll review that when it arrives. Until then, I'm going to have to make do with this resistive load. The nice thing about this is maybe the cost of this was under 30 bucks, maybe 25 bucks. You can get the resistors real cheap. You can get the switches cheap. Box came with Jameco. I don't have a thermal cutoff in here, but I will probably add some thermal cutoffs. I'll probably glue with thermal glue one of these to the top of each resistor, splice that lead, and then there will be thermal cutoffs to prevent overheating. Okay, let's start by taking a look at the DPX5005. So there's 3 different variants you can get this in. I have the USB variant, which will include a USB communication option so you can control it from a computer. There's also a Bluetooth, and there's the kind that has no options. Here's the little daughter board for USB. Here's the module itself. So you can see it's got 2 pins for in, plus and minus, 2 pins for out, plus and minus. Got a removable terminal block. Those are real handy because you can wire them up and then plug them in. Behind here I see what looks like a couple of shunts. Let's put it back together. We've got some TO220 packages coming up here to the heatsink. Those could be regulators, those could be MOSFETs, power MOSFETs. We've got some big capacitors, we've got a big inductor over here. A lot of things that you'd expect to see on a switch mode power supply on the front. We've got an on-off button, an encoder, good detent stops on the encoder, it's the kind you can push in, and 3 little buttons there and a display. Okay, so let's try out this DPX5005. So I've got power going into it here. This is a case I built up previously. It just has a barrel jack, goes to a switch and then powers the module. Then we have power going out into my DC load. All 4 resistors switched on. So let's take a look at this. Let's turn on the DPX5005. You can see it's reading volt in of 48.2 volt. That's kind of nice. It tells you how much voltage is coming in. And we've got a set point of 7 volts at 5.1 amps. Let's go over here. The interface I do find a little bit cumbersome, but you do learn how to use it. So 5 volts, and then let's go over here to amps. 5 volts, 5 amps. And we've got it preset. Now it's not actually on until I push the on button. So as soon as I push the on button, we will discharge 5 volts at up to 5 amps into a 7.5 watt resistor. You can hear the Mastech power supply that I'm using to power this spun up a little. We're doing 5 volts, 0.6 amps. If we got Ohm's law out and calculated that, we would probably figure out that is around what happens into a 7.5 ohm resistor. But we can take and we can start ramping the voltage up. Let's see how high we can go. 8, 9. So there we're up to 20 volts, 50 watts of power. Really no heat coming out of the DC load yet, although 50 watts is a considerable amount of wattage. And that's up to 2.6 amps. Let's keep going. 24, 25. Now we're up to 30 volts into this DC load. Is 118 watts. I'm just going to keep going until we see it current limit. So now we're at 40 volts, 5 amps. We have hit the constant current mode. We're at 5 amps. The DC load, still not really hot over here. I can feel that, yeah, the case on this thing is starting to warm up. I can feel it getting hot. Not really blowing hot air out, but we're pulling 192 watts through this power supply. So anyway, the heatsink is around 40 degrees Celsius. Regulators 42, 45. Some components right before the regulators are about 70. What is that? That could be the regulator IC, or I'm not sure what that is. Over here, this capacitor is about 32. These capacitors down around 23. This big power inductor on the side is 36. So yeah, that's kind of nice. This power supply is not getting really hot, even though we're pulling quite a bit of electricity through it. What else can we do with this thing? Well, there is a menu someplace. I think if we push the set button, you could go down. It's nice. This thing does have over voltage protection and over current protection and over power protection. So you could set it to limit it 51 volts, 5 amps, 265 watts. Set the brightnesses. It's kind of a full-featured little module. I can see why people really do like this thing. You get a lot of performance in a small package, and it's not really all that hot. Okay, so let's take a look at the RD6006. There's a QR code and a URL to tell you where to get more information. So boom, here we have a temperature sensor. It's a little thermistor right there with a connector on the end. Here is the Wi-Fi board. So I bought the Wi-Fi version of this module. Here are some terminals that must fit those, and a spare fuse. And here's the power supply. So we'll actually try out the user interface and the buttons in a moment, but for now, let's just look. It's got some binding posts on the front. That's great. Like decent quality binding posts. My connectors actually fit, which is nice. Compare this to my Maztec power supply where they won't actually fit, which is really annoying. So looking inside, there's a spot to install a battery right there. You'll need a CR1220 battery. I bought these ones on Amazon. Does not ship with a battery. I think the battery is just used for the battery backup for the clock. It's just as well it doesn't ship with it because, it probably allows them to avoid some shipping restrictions for lithium batteries. So there's two circuit boards. I'm not going to take it apart, but this looks like the primary power driver board, and then there's a display and logic board under it. We've got a fan with a heat sink. You've got your power inductor. Let's see, that's the input there. So here's another inductor. Maybe that's to reduce noise on the input. I'm not really sure. There are two socketed fuses. One is here by the input, one's there by the output. You've got a relay, perhaps that turns the power on and off. I would assume your voltage regulators are under this heat sink. Got three nice big capacitors. Brand on the capacitors, it says CD/ECD. I'm not familiar with that brand. This, I would say, is perhaps our current sense resistor. Nice big resistor. Looks alright. Banana jack binding posts. It looks like they go all the way through and they're soldered to this backboard. I see three big spots to solder it there. Now let's try out the RD6006 by Ryden. You can see it has this annoying blinky green light. There's one thing I don't like about this thing. It's the annoying blinky green light when it is off. I wish there was a feature to disable that. So the other thing I don't like about this meter is these three binding posts. So I like to be able to plug in one like this, a double banana jack, which you can plug in, but this green post in the middle here is neither ground nor negative. It's actually a battery charging terminal, which, first of all, why is it green? That seems like a dumb color when everyone else uses green for ground. And second, it makes it so that I can't really plug in a two-wire banana plug like this to both ends of the power supply at the same time. So what I did internally, I ran some wires over. I put my own banana jacks over here on the side. You can see I've actually mounted this thing on my wall because I have decided this is the power supply I'm going to go with. But aside from those two negatives, the blinky light and the layout of the binding post, it's pretty good. Let's give it a shot. So we can turn it on. Right now it's trying to connect to a PC, so it does have the ability to control this by Wi-Fi. It's going to fail because the PC is not on. I've actually tried this with their PC software. It does actually work. If the PC was on, we could do it. It's a little bit weird in that the way they implemented it from a client-server perspective is the power supply is the client and the PC is the server. So the power supply is kind of calling out to connect to the PC rather than the PC calling in to connect to the power supply. That seems, from a computer programming networking perspective, that seems completely backwards to me. And I don't know why anyone would do that, other than maybe they're either not familiar with how networking client-server paradigms usually work, or they're just had some other application in mind. But anyway, it's powered on now. See, it's got a great display that's telling us all kinds of information at once. We can see we've got the 48 volts going in. It's currently preset for 5 volts, 6 amps. We have the over voltage and over current are set up. Now it has some nice light up buttons that if we want to do V set for voltage set, you see it lights up, and then we've got a cursor up there under V set. I set for current set does the same thing. We can move our cursor back and forth. Much nicer interface than that little DPX6005 module, just by virtue of us having a lot more real estate both on the screen and for buttons and such. It does have, there should be a menu page, shift and menu. You see it's got all kinds of stuff you can do in here. You can control the beeper, the logo, the language, the interface, all kinds of stuff here. Address, date, time. It actually has a clock in it, a battery backed up clock. But anyway, let's try kicking some power out of it. So we'll turn this on. We have my DC load hooked up as usual. Turn this on. Okay, we've got it set for 5 volts. We're getting 4.99 volts, 0.663 amps. And let's try ramping up the voltage. Now, you can see it is calculating watt hours, amp hours, and it does have a temperature sensor in there. The temperature sensor is actually just free floating on a probe inside the case. But let's try ramping up the voltage. So we'll go into V set, 5 volts. There we are. We're at 20 volts. With a 6 amp current limit, we're getting 2.647 amps and 52 watts of power. There we go. So now we're up to 40 volts. Our current limit is at 6.1 amps. So we haven't actually hit the current limit yet. And we're putting 5.2 amps out with 209 watts through this power supply. So let's try to go a little bit higher. 43, 44. So we're actually at about our limits on what we can do here. The resistive load's getting pretty high. We're doing 268 watts through this power supply. The input voltage is 47.23 volts, and we're still 22C inside. It's not getting super hot. While we're here, let's go over here and play with the current settings. So if we wanted to reduce the current, there we go, 2.1 amps. Now we're in constant current mode. So we've set our voltage limits at 46.23, 2.1 amps. We hit the 2.1 amps. You can see the actual there, 2.092. And then the voltage at that constant current mode at 15.96 or so. So this thing is working out great. Here, I'm gonna bring it on down a little bit more, just so we're not sending off a lot of heat. You know, I really like the UI that I can move the cursor back and forth like that. It's really why this has become my my favorite power supply, and the one that I decided worthy of sticking on my wall. Let's see, what else can I show with this? So it does also have a memory feature. So if we do mem and 1, that will store this preset in memory 1. And then if we could do a shift and 1, and that will restore preset 1. So that's kind of handy. Well, it turns it off automatically, but turn it back on. So that's kind of handy. If you had lots of preset tests that you do or equipment that you work with, you could store, you know, those 9 presets. That would be pretty useful. And like the other supplies, it does have the overcurrent, over voltage protections. The watt meter is nice. There's a whole battery charging feature that I suppose people who are charging batteries would find useful. This thing is just loaded down with features. It seems to run pretty cool. It didn't heat up at all. It actually does have a little fan in there, I think, if it needed to. Okay, for our final meter, let's check out the DPX6005. This is it here. This front panel, you know, when I saw the pictures of it on eBay, I thought it was like CNC'd aluminum. It's actually laser cut acrylic that is black on one side, which is, you know, maybe fine, but not as durable as I had expected. Let me take this off of there. It does have a nice fan down here. You've got you know, some beefy capacitors, a couple of regulators or MOSFETs or something on the heat sinks. It's your inductor. Over here is a board that will let you do USB to it. It's actually kind of weird that it has a USB-A jack instead of a USB-B, and they give you like a funky A to A cable. Strange. But, you know, it seems like a functional module. The thing I don't like about this is just how deep it is. Compare this module to a DPX5005. Look at how much smaller the DPX5005 is. Sure, the DPX5005, it lacks the beefy heatsink, and it lacks the beefy capacitors, and it lacks the fan. But we just tried out the DPX5005, and it worked pretty darn well. So the bigger capacitors are probably going to give you better filtering on this. A bigger heatsink and a fan is always nice. Anyway, let's try this module out. Okay, let's turn it on. Turn it on. 5 volts, 0.65 amps, 3.25 watts in constant voltage mode. Now this button here lets me move the cursor back and forth. I don't know what lets me move the cursor down. Something has to let me go down. Set. Okay, yeah, so set will move between the volt and the amp settings. So let's try ramping the voltage up. Right now we're in constant voltage. So the fan has kicked on. Fan is spinning. I'm at 9 volts. Let's go 10 volts, 1.31 amps. Bring it on up. 20 volts, 2.75 amp. Currently it's set for a 3 amp current limit, so let's go up there. Now we've hit the current limit. Yeah, so we've set our voltage for 24, went into constant current at 3 amps, 23 volts. This constant voltage, constant current light seems to be blinking. Let's see if we can go down. We'll raise that current limit up. Raise it all the way up to 5. That's as high as it goes. And let's see how many watts we can get out of this thing. There we're up to 30. Okay, so right now we've got it set for, what, 38 volts? It's doing 187 watts, 4.94 amps. If I go any higher, we will hit that constant current limit. Yeah, so we're current limiting now. Not too hot. One would question, you know, why we need a fan when it's not at all hot. So it seems to be stable. It seems to be working. Let me go down. I can fool with this. Take the amps down a bit. 1 amp current limit. Working fine. What does the ML button do? I would say the ML button is something to do with a memory feature. We've got a shift button. What does that do? I don't know. Shift set. There's got to be something that brings up a menu like the other ones. Oh, there we go. So shift set, and that has brought up something where I can do my over voltage, over current, over power. Well, that's back and forth. So set, yes, that'll keep going down. Display address. Yeah, so there's some configuration for serial. So certainly it has all of the same features as the other ones. Boy, I don't even know how I exit this. Shift set again. Okay, yeah, shift set, prod it back out, turn it back on. So in conclusion, we've looked at these three modules. They're three popular modules that you will find on Amazon, eBay, AliExpress, and the like. I did not look at the ripple on the oscilloscope. That's something maybe we can do it in a future video. It'd be interesting to see how much the ripple is on each one of these supplies. I imagine on any of them it's not really great because these are switchers, and they are switchers without a lot of filtering built into them after the switching stage. So I would expect, some fairly significant ripple. If you want something ripple free, you probably want a linear supply. So which one would I buy? Well, it really depends on budget and space. I would not buy this one. I don't see how this DPX6005 offers anything that the other modules don't. It's bigger. Sure, it's got the big heatsink and fan, but that really didn't seem to do a whole lot for me. So I don't think I would get that one. I would think my choice would be between these two. And between these two, the RD6006 and the DPS5005, it comes down to size and price. You're paying a lot more for this to get a really nice UI and a really nice display, but it's big. Depends where you want to fit it. The DPS5005 is a very well reviewed, very popular, YouTube videos all over the place on it, module, and it's the relatively cheap one, but you don't have the nice UI that you have with the RD6006. So money was no object and space was no object. I would certainly go without RD6006. Money or space were concerns. I would go with the DPS5005. Thank you for watching my video. Please visit my website at www.smbaker.com for more electronics projects and sandrail stuff. Bye.